In shipbuilding, no drawing, plan, or system layout moves forward without the approval of a classification society, commonly referred to as class. But why is this approval so essential? Is it just paperwork, or does it serve a deeper purpose? Let's break down the critical role of class approval in ship design and why it's a non-negotiable part of the shipbuilding process. Ships must comply with numerous international conventions and codes that govern safety, pollution, prevention, and vessel integrity. These include safety of life at sea or SOLAS, marine pollution prevention, known as MARPOL, the Load Line Convention, ISM, and ISPS codes for safe management and security. Classification societies ensure your design aligns with these standards so the ship can operate legally and globally. Design approval by class ensures that the ship is structurally sound, including the hull decks and bulkheads. It also means the vessel is equipped with safe and reliable piping, electrical, and machinery systems. Plus, it's built to withstand fire, flooding, and extreme sea conditions. In essence, class approval protects lives, cargo, and the marine environment. Every ship is unique, but class rules provide a standard framework for material selection, such as approved grades of steel and pipe specifications. They also cover welding procedures and joint testing, as well as system layout and installation practices. This helps maintain uniform quality, especially when ships are built across different shipyards or countries. Without class approval, a vessel cannot be insured, won't be accepted by charterers, may be detained by port authorities. Class acts as a stamp of trust. It assures insurers, investors, and operators that the ship is seaworthy and built to global standards. Class approval isn't a one-time process. It includes design reviews, construction inspections, witnessing tests like pressure tests and stability tests, and periodic surveys during the ship's operational life. This continuous oversight ensures that the ship remains safe, compliant, and well-maintained. Here are some of the many design documents that must be submitted for review. General arrangement drawings, hull structure and scantling plans, piping and instrumentation diagrams, machinery and electrical layouts, fire and safety plans, stability calculations, and isometric spool drawings for major systems. DNV, ABS, Lloyd's Register, Bureau Veritas, Class NK, RENA, KR, CCS, and others. Each society has its own rules and portals for digital submission and approval. Class approval is far more than an administrative step. It's a critical safeguard that ensures every vessel is safe, insurable, and legally fit to sail. Whether you're designing a fuel system, a ballast line, or an entire engine room, always remember, if it's not approved by class, it's not going to see. Class Submission Drawing Checklist. These documents are grouped by major systems and ship construction phases. First, the general arrangement and capacity plans. This includes the general arrangement drawing, which is essentially the top-level layout of decks. Then we have the tank capacity plan, the watertight and weathertight integrity plan, and the subdivision and damage stability drawing. Next, we move on to hull and structure. This section requires several detailed drawings, starting with the midship section drawing and the shell expansion plan. Additionally, we need deck and bottom structure drawings, longitudinal and transverse bulkhead plans, and a framing plan. Hull scantling calculations are essential too, along with stern frame and rudder details, and finally hatch combing and cover details. Now, let's talk about piping systems. Each major system has its own set of required drawings. For the bilge and ballast systems, we need P and ID, arrangement, and isometrics. The fuel oil system requires P and ID and transfer and service system layout. The lubrication oil system needs a system diagram and pipe routing. For fresh water, a cooling system diagram is necessary. The firefighting system requires a fire main layout and hydrant locations. Compressed air systems need control and start air diagrams. Sewage and grey water systems require system layouts. Exhaust and ventilation systems need duct routing and sizing. And for cargo piping, we need tank stripping and transfer lines. Additionally, pipe material specification sheets, valve lists, and penetration schedules for pipes through watertight boundaries are required. All right, moving on to machinery and the engine room. Here we have the engine room arrangement, which is crucial for the layout and functionality of the entire engine space. Next, we have the foundation drawings for the main engine and generators, ensuring everything is securely mounted. Then we look at the shafting arrangement and shaft alignment calculations, essential for smooth and efficient power transmission. The engine control system diagram follows, detailing how the engine is monitored and controlled. Finally, we have the fuel treatment and purification layout, which is vital for maintaining fuel quality and engine performance. Now let's dive into the electrical systems. First, we have the single line diagram for the main power distribution, which outlines the electrical flow throughout the vessel. Then we see the lighting and socket layouts, ensuring proper illumination and accessibility. The emergency power system drawing is next, showing how power is maintained in critical situations. We also have the earthing and bonding diagram, crucial for safety and preventing electrical hazards. The battery room and UPS layout follows, detailing backup power sources. Finally, we have the fire detection system plan and the alarm and monitoring system diagram, both critical for safety and early warning. Lastly, let's talk about safety and fire protection. We start with the fire control plan, which outlines the measures and equipment in place to combat fires. The escape route plan is next, showing the safest and quickest ways to evacuate in an emergency. Then we have the life-saving appliance plan, detailing the locations and types of life-saving equipment available. The fire integrity plan follows, specifying the fire-resistant boundaries like A60 and B15. We also have the fire and gas detection zone maps, crucial for identifying and responding to hazards. Lastly, the emergency shutdown system diagram, which is vital for quickly and safely shutting down operations in an emergency. Stability and strength are crucial for any vessel. We start with hydrostatic curves and cross curves, which are essential for understanding the ship's buoyancy and stability. The Intact Stability booklet provides detailed information on the ship's stability under various conditions. Damage stability calculations, including flooding scenarios, are performed to ensure the vessel's safety in case of breaches. Longitudinal strength calculations assess the ship's ability to withstand bending forces. Lastly, the loading manual offers guidance on proper loading to maintain stability and structural integrity. Now let's move on to some miscellaneous but equally important aspects. Navigation light arrangement ensures that the vessel is visible and compliant with maritime regulations. Signage and marking layout are essential for safety and operational efficiency. Ventilation calculations help maintain a healthy and safe environment inside the ship, and, if required, a soundproofing plan is developed to minimize noise and enhance comfort. Here are some sample templates you can use or create. For P&ID templates, tools like AutoCAD P&ID or Aviva diagrams are recommended, featuring standard symbol libraries for valves, pumps and fittings. Spool drawing templates include weld joints, part lists, bend radius and fit-up instructions. GA drawing templates are layered for hull, machinery, systems and accommodations. The Bill of Materials, or BOM, is available in Excel or database format for each system, detailing pipe size, type, length and quantity. Valve list templates are sorted by tag number, type, pressure class and system. Lastly, the penetration seal table is an Excel template, indicating pipe pass-throughs, location and seal type. If you want ready-to-use templates, I can provide a downloadable Excel pack including a valve list penetration schedule and BOM. AutoCAD DWG templates are available for spool drawings or P&ID. Additionally, a sample GA drawing PDF with layer breakdowns can be provided.